Hello. Let's do the multiple choice first. And I think that I need to start here. So the first question, in a horizontal pipe with steady flow, the head loss is mostly due to, of course, friction. That's why they're called major losses. Choose which one of the results is an increase in total energy. So whenever we look at the expression for total energy, let me write it here. So you have P1 over gamma plus V1 squared over 2G plus C1. And if we're looking at 2 points, right, P2 over gamma plus V2 squared over 2G plus C2. And then we have the losses, and here you would have any gains. So the losses would be due to major losses or minor losses, and then the gains or step up would be due to something that increases the energy. So something like a pump would increase the energy. And then the other thing is, as you decrease the diameter, you increase the velocity. So in terms of total energy, a decrease in pipe diameter will do that. Now whenever we look at what would decrease the total energy, we have valves, we can have turbine, we can have an entrance, an exit, and then if we increase the pipe diameter, then you get a decrease in total energy. The next question, when there is a decrease in pipe diameter, the difference between the hydraulic grade line and the energy grade line decreases. So whenever we look at the energy grade line, it includes pressure plus velocity plus elevation. And then the hydraulic grade line would only include pressure and elevation. So the difference between the two is this velocity. So is the answer here, might as well have it here. So whenever there is a decrease in pipe diameter, as you decrease the diameter, the velocity increases. So therefore, this difference increases. So the difference between the hydraulic grade line and the energy grade line increases. So this is just describing the two energy grade lines. I'm giving you this as extra. The amount of energy required to change water from one phase to another phase, no matter what phase it is the latent energy. So if you're changing from solid to liquid, is the latent energy or heat of fusion, and if it's from liquid to vapor, then it's a latent heat of vaporization or the latent energy of vaporization. Because I'm not telling you which one is it, just from one phase to another. The next question, to change water from one phase to another requires a change in heat or pressure, and we can do it exactly. So remember what we mentioned, how if we decrease the pressure low enough, the water will vaporize. So that's what happens in cavitation. And then of course we can change the heat, which by increasing it. So this expression is true, and you can do it heat or pressure. All of the following are true except. So the density of water is graded as 4 degrees Celsius, and I told you in the exam that the table you have in your manual is 5 degrees Celsius. Assume that it's the same. Specific weight can be found by multiplying density and gravitational acceleration. So this specific weight, density by gravitational acceleration. The densities of objects on the moon are the same as they are on Earth, and this is correct. Density is mass over volume. The specific weights of objects on the moon are the same as they are on Earth. No, because the specific weight is rho times g, and the gravity, acceleration of gravity on Earth is larger than the acceleration on the moon. So this one is the one that is not true. The next question, and I guess I just copied this twice. Gauge pressure is defined as the pressure measured above the atmospheric pressure. This seems to be true. Let's see that whenever we had the absolute pressure equals the gauge pressure plus the atmospheric pressure. So the gauge pressure is above the atmospheric pressure. The pressure measured plus atmospheric pressure, this is the absolute, not the gauge. The difference in pressure between 2 points is just the difference of pressure. It's delta P. The pressure expressed in terms of the height of water column, no. So this expression here is the correct one. The center of pressure on inclined plane surfaces is at the centroid, is always above the centroid, is always below the centroid, is not related to the centroid. So let's see. The pressure on a point is, you have a inclined plate. Let me see if we have this. If you have an inclined plate, we have the water and we have the inclined plate, and this would be the centroid. And we calculate the average pressure at that, but the center of pressure, so this would be YC, but the center of pressure would be lower. And you can see this expression, the center of pressure would be the centroid plus something else. So it'll always be below the centroid, not above the centroid. Is never above the centroid, is not at the centroid, is related to the centroid, so it will be always below the centroid. The next question is related. It says the location of the centroid of a submerged plane area and the location where the resultant pressure acts on the area are identical, and we saw that is not true, so this is false. The significant distinction between the Bernoulli equation and the energy equation is the Bernoulli equation does not account for energy losses. There is no difference. Bernoulli includes major and minor head losses. Bernoulli includes pumps and turbines. Well, Bernoulli is this. So we have 2 points, and we mentioned this in class. So this is Bernoulli, and Bernoulli does not account for losses. So the Bernoulli equation does not account for energy losses. So this is a multiple choice, but it is a problem, a short problem. So the question is, water is flowing through a 3-inch pipe. The velocity of the water is 0.15 feet per second, and the kinematic viscosity of the water is 1.92 times 10 to the minus 5